Good morning. This lesson is about multiplying radicals with different indices. Now, before I give you the example on how to multiply with different indices, I will give you first an example that have radicals that have the same indices. Now, the reason why I'm giving you this first is this will serve as a review for multiplying radicals. So when we multiply radicals, the indices should be the same. Like for example, in this case, all we need to do is multiply the coefficients, that's negative 2 and 5 here, which is equal to negative 10, and then multiply the radicands. And they are positive 3 and positive 27, so that will be equal to 81. And of course, whatever the result is, we need to make sure it's in simplified form. We know that 81 is a perfect square number, and the square root of 81 is 9. So this is equal to negative 10 times 9. And our answer here will be negative 90. All right, so that's how we multiply radicals with the same indices. Now here we have a problem because the indices here are the same. The rules of multiplying radicals is not that difficult. We just need to make sure that the indices are the same so we can multiply the coefficients and the radicands. Now in case the indices are different, we need to do something. Well, what is that? First, we need to look at the indices. We have number 3 here, and there, since that is a square root, the index there is number 2. So I'm going to write 3 and 2 here. And then we need to find the least common multiple of number 3 and 2. Multiples of 3 are 6, 9, 12, 15, etc. Multiples of 2 are 4, 6, plus 2, 8, plus 2, plus 2. Now here, maybe you're seeing, oh, there's a number 12. Yeah, that's a multiple of 3 and 2, but we're looking for the least common multiple of 3 and 2. And therefore, we're looking at number 6. Since 6 is the least common multiple of 3 and 2, I'm going to make this 3 equal to 6 and that 2 equal to 6. And how? By multiplying a certain number. So what number are we going to multiply to 3, okay, to make it equal to 6? That's right, it's positive 2. So this radical will be equal to 4x, 3 times 2, this is the index, and then the radical, or the radicand rather, x raised to 1, we also need to multiply the exponent by positive 2. Okay. Next, the other radicand, or radical rather. This is negative square root of 5 y squared. So the index is 2, we need to make it equal to 6. And the number that we will multiply to 2 is 3. So 5, that's raised to 1, and then multiply that by 3, y raised to 2, and then multiply that by 3. Okay. So first, let's evaluate or simplify first each radical. So 4x, this time this is going to be 6th root of x squared. And this will be negative 6th root of 5 raised to 3. And then y raised to 6. Now, since the indices are the same, we can now multiply the coefficients and the radicands. So 4x times negative 1, there's a 1 there. So that will be negative 4x. 6th root of x squared, okay? We cannot simplify that. 5 raised to 3 is 125, okay? Now, y raised to 6, I think, is a perfect, we can simplify that, okay? So y raised to 6th root of y raised to 6 is just y. So that means, okay, I'm just going to erase this. So 6th root of y is y. So I will put the y here. Then 6th root of 125x squared. So our final answer is negative 4xy, 6th root of 125x squared. Right? So that will be the answer for this problem. Okay, I'm going to give you 2 more examples. Let's consider this one. So again, when multiplying radicals that have different indices, the first thing we need to look at are the indices. 4 and 8. So what's the least common multiple of 4 and 8? Multiples of 8 are 8, 16, and then 24. Maybe we can stop there for a while. 4 after that is 8, of course, and then 12, and then 16. Now it's obvious that 8 is the least common multiple, which means that we will not multiply a number to 8 to make it equal to 8. Well, maybe 1, but that means it's already 8. So we will not do anything here. But with that number 4, we need to multiply what number to make it equal to 8? That's right, it's positive 2. So this radical will be equal to 5a, 4 times 2, and then b squared times 2. Nothing will change here. So a raised to 2, b raised to 3. So this will be 5a, 8 root of b raised to 4, 4 8 root of a squared b raised to 3. All right. So now, since the indices are the same, I think we can now multiply 5a and 4, and that gives us 20a. So 8 root of a squared, b raised to 3, and b raised to 4. So there we need to add the exponents. It's b raised to 7. And I think we cannot simplify this any further, so this will be the final answer. Okay? Let's go to the last example. Again, the first thing we need to do is look at the indices, 6 and 4. So 6 and 4. What is the least common multiple of 6 and 4? 6, 12, 18, 24. Stop there for a while. And then 4, 8, 12. There you go. Here. 12 is the least common multiple. So which means I will multiply what number to 6 to make it equal to 12? That's right, it's number 2. So this is 3x squared, 6 times 2. Then x raised to 1 times 2, y raised to 3 times 2. Okay, with this radical, negative 7y, 4 times 3, right, to make it equal to 12. And then 3 raised to 1 times 3, x raised to 2 times 3, and finally y raised to 5 times 3. All right, let's simplify each radical first. This will be 3x squared, 12 root of x squared, y raised to 3 times 2 is equal to 6. So we're done with this radical. This is negative 7y, 12 root of 3 raised to 3. Let's evaluate that one. That's 27, right? And then x raised to 6, y raised to equal to 15. Now we can multiply the coefficients. 3 times negative 7 is negative 21. X squared times y is x squared y. 12 root of 27. X squared and x raised to 6 is x raised to 8. We add the exponents. Y raised to 6 times y raised to 15 is equal to y raised to 21. And I think we can simplify this y raised to 21, right? So what I'm going to do is I will factorize first that y raised to 21. So x raised to 8, y raised to 12, because we want the exponent to be 12, so we can simplify it. And then y raised to 9. So the final answer is going to be negative 21 x squared. So 12 root of y raised to 12 is just y, and there's a y outside. So y times y is equal to y squared. 12 root of 27 x raised to 8, y raised to 9. So that's how we multiply radicals with different indices.